stuff on here. Okay. And so we are now in chapter 4. We took a test over all that good stuff. We are in chapter 4. We are starting the section on finance. So there is 4B, 4C, and 4D, I believe, are the 3 sections we're doing. 4A got cut, 4E I cut. So 4A was about personal finances. So there is like a little bit, maybe some good stuff in there with finding monthly expenses. And so if they give you something that is yearly and you want it monthly, divide by 12, something like that. If they give it to you weekly and you want a month, about 4 weeks in a month. So if you wanted to generalize it, I'd probably say round it to 4 weeks in a month or something. But they give you like some tips on finding your monthly budget, which is pretty important. That's how we pay our bills typically, is per month. We have monthly bills. If we get paid, it's usually on a monthly basis. Sometimes it can be otherwise. Wow. And so what was I going to say? So we are doing 4B. So 4B, I have simple and compounding interest is basically what we started learning about in this section. There's also this thing called annual percentage yield, but talk about a little bit more about it later. But the section mostly, I think, simple and compound interest, knowing what those things are, knowing how to find those. If you know how to do those things in this section, you're probably pretty well off. The other thing, that is this section. And so I have this guy, Rip Van Winkle, that's his name. Took me a second. But I have Rip Van Winkle here. And so this section I sort of think about as like the Rip Van Winkle problems. Like I put some money in and I don't touch it. I just fall asleep on it, basically, right? So I fall asleep on it for a lot of years and I don't do anything else to it. I don't touch the account. It's just there gaining money. That differs from like the next section that we're going to talk about, which is savings accounts. So when we talk about savings accounts, if you look at the formulas or the formula sheet, you might notice like those savings accounts, they start introducing this variable of payment. So the big difference between this section and the next section is going to be that variable of payment. And joining it. And the last one, the last section that we're going to talk about, joining the game. No, what's Oregano Olaf? That's a good one. And so the last section we're going to talk about is paying loans back, which is in 4D. So we'll talk about in 4C, we'll talk about saving up money to pay for your education. In 4D, we'll talk about paying back loans to pay for your education. So we'll get both of those ends in somewhere here in financing. Any questions so far? Should we jump into it? Probably ready to get into it. Get it over with. First problem, what does this say? Full question. Okay, so simple interest. We want to calculate the amount of money you will have in each account after 5 years. I think there is a formula for this. If I'm being honest, I usually just find out what my interest is and add it to my deposit. So I usually don't bother with the formula for this one. And the next question, I think they're going to ask compounding interest. So I will throw the formula sheet in their next question. So we want to calculate the amount of money you have in each account after 5 years. So we're going for 5 years. We're depositing $800 into an account with an annual interest rate of 5%. So I kind of said it. First thing you probably want to do is calculate interest. So what is 5% of 800? That's going to give you the annual interest. You're going to want to do that 5 times for the 5 years. And then you're going to want to add, that amount is your interest. You're going to want to add it back to your deposit. And so it's important to at least give these things a try. And so I think in general for this section, rounding is really going to become probably like an issue for some people maybe. But this is one of those sections that you're going to have to be careful about where you're rounding things to. I'll talk a little more, and then this one's not too bad. The next one maybe talk a little bit more about like where to round. When we actually start throwing things into a formula, it might be easier to talk about how the formula works. But everything in this section, I'm pretty sure I got it rounded to the nearest whole dollar. As long as you get within a couple of dollars of where you should be. And again, that's kind of relative. If we're talking about $1,000 and you're like $2 off, it's not a big deal, right? But if we're talking about like $5 and you're $2 off, that's kind of a big deal there. So it's got to be relatively close, right? All right, I'll give you all a minute. This one should be pretty quick though. Okay. I got 3 people falling asleep already. Come on. And so I hope what you got was 1,000. You're telling me. See, the wrong answers are more exciting. I'm not sure you're getting 32. The code should be at the top of the screen. 309-558. Okay. So don't forget to put your $sign. But if we want to deposit $800 in a true account with 5% interest, this is simple interest. So if they tell me simple interest, my annual interest is $40 is what I'm going to gain each year. And so the big difference with simple interest and compound interest is in simple interest, we're only taking interest on this $800 initial dollars. We're only taking interest on our principal. We're doing it for 5 years. It's going to be $200 over the 5 years. We're doing that $200 plus the $800 that we started with, and we're going to have a total of $1,000 accumulated amount. Okay, and then the difference between simple and compound is when we're compounding, we're taking interest on the initial principal, but we're also taking interest on interest each year. It's a little bit more complicated, so we need this sort of formula probably. This is going to be the formula sheet pretty much that we're going to use, or that I'm going to give you. So I'm not expecting you to memorize stuff in this class for the most part. Math is not really about memorization. It's about the process to get there. So I will give you the formulas. You have to know sort of like what the variables mean to put them in. So A is accumulated amount, P is principal, 1 plus my APR is my annual percentage rate, Y is the number of years. So I believe in 4B, I introduced these first three equations. Savings plan would be 4C. I think this is also in 4C. This is definitely 4D. So that's where we're going. So it should be one of these three, if I'm being honest. I don't think there's anything that says continuously compounding in our homework examples. So yeah, just round to the nearest whole dollar, I think, on everything in here, in this section. For the online stuff. Okay. And so this problem, and it kind of does it here. This is compound interest. If interest is paid once a year, this is if interest is paid n times a year. This is if it's continuously compounded. So it's kind of like we're infinitesimally compounding it. Would break it into like sort of infinitesimally small little time segments, basically, right? Compounding more than once per year, use the appropriate compound interest formula to compute the balance in each account after the stated period of time. So if we invest 4,000, 4,000 is invested for 20 years with an APR of 6% and monthly compounding to the nearest dollar. Did I skip? I skipped a variable here, huh? I started talking about the variables and then I think I got sidetracked. So if this is compounded once per year, so this is if it's compounded n times per year. So n is the number of compounding periods. And so if they say monthly, n is going to be what?
12.
Yeah, 12 months in the year. If they say quarterly, there's 4 quarters in a dollar. Semi-annually or biannually, whatever they want to say, it would be twice a year. I think for the most part, a lot of times this n, it's either going to be the number of compounding periods, it's going to be the intervals of payment, it's going to be one of those sorts of things. It's when we're crunching the numbers and finding things out. And so quite often it's going to be monthly, right? Because we typically pay things monthly. So we're going to use monthly quite a bit, but it could be another number. On this, the other thing that's here that's kind of weird is that lowercase e, that is known as Euler's number. So I think I've spelled this out before, but it's like EULER, right? Euler. That's where the small case e's comes from. That is the natural exponential, is also another thing that it's called. If we remember taking logs and logarithms, kind of like the natural log, it is the inverse operation of that. And so it's just this number. It's sort of like pi. It appears in nature, so we talk about it. It comes up here as a limit, so we talk about it here. But that's probably enough talking about it. Probably let's do it. If we do 4,000 invested for 20 years, APR 6%. We know it's monthly compounding. So if I'm looking at these three, I know it's not compounded once per year. That would be this one. I think I'm going to have to use this one and plug in my information. So what was it, 4,000? What was the interest? 4,000 with a 6% interest, compounded monthly. And we're going to do that for 20 years. The other thing I will warn you is you should be doing exponents here, right? A lot of people mess up and they do multiplication instead of exponents. Those are different things. You're gonna have to find some sort of device that does exponents. And I would not round until like the very end. I would not round before you take your exponents. Exponentiating things, in case you hadn't noticed, it makes things grow really quickly. And people, if I had to place money on it, people will underbet how quick things grow. It's just very sort of counterintuitive to what we're used to. So round it to looks like you might be rounding right.
Wait, so on the formula, compound interest formula for interest paid in times per year, that like exponent past the parentheses, it says NY, right?
Yes, this is the exponent.
So you would put 12 months for M, so you put 12, and then what? I'm confused on what you would input for Y.
So Y is the number of years, which here would be 20 years.
Okay, gosh. Thank you. Appreciate it.
And so if we think about it, if we're compounding it monthly for 20 years, this actually gives us the total number of compounds that we do. If you're compounding it each month for 20 years, you're going to do what? 12 times 20 or 240 different compounds. That's what's happening. So if you look at, this might be an interesting thing to bring up again, but if we paid it one time per year, right? It would look like 1 here. That would just be our APR. 1 times Y would just be our Y. We get back to this original formula. So this is a little bit of a simpler formula, but it's basically the same formula if we just plug in 1 to N. Don't forget your money sign. All right, so hopefully you're trying something, but just to recap, I'm hoping you're looking at this formula. I'm hoping for your principal is 4,000. 1 is the number 1. APR, it is 6%. Don't forget to convert that to what? 0.06. My N is 12. My N here is 12. My Y here is 20. So the thing that really comes up here now is the order of operations. We have to sort of do things in the right order. We're at 8, 17. Oh man, what's going on? Yeah, I don't know, man. This is only the second question. I know we haven't got too many questions, but we got more parts to go through, man. I gave you the numbers to plug in. You should be trying to do some arithmetic of some sort. Even if it's wrong, like do something. Yeah, I guess my other advice for the section is to have a calculator that ain't your phone that can do exponents, right? Okay. What are y'all doing? 13,240. Okay. Where do we get 48? 13,240. 13,241. Those should be correct. All right. So I'm not sure where these other numbers are coming from. If you know, or if you want to contribute and help someone out, I can guarantee you if you did it wrong, someone else did it wrong. Same way.
I'm having a hard time understanding the how to do the exponents. Because if I do it on the calculator, it's like in the 100,000s.
It shouldn't be in the 100,000s. Because if we fill in everything in, it should look something like this. If we do the 0.06 divided by 12, it gives me what, 0.005. And I can also do the 12 times 20. And so I want to raise 1.005 to the 240. Is that what you were doing?
Yeah.
Should give you something like 1.005 to the 240. It should give you something like 3.31 when you do it.
Okay.
So again, like I would have to look at the device or whatever you're using, but a really common mistake is people try to multiply these two numbers or do something like that. So definitely this is the time to figure out your calculator or whatever device you intend to use. Like, I don't know. Sometimes people, I don't understand study habits sometimes. It's like you don't practice for the show in a way that you're not going to play it, you know. Anyway, any questions on this? This is definitely calculator or device check time. Make sure you have something that is not your phone that you can do exponents on. Whoa, what are we doing? Let's get past it. Oh, what happened? 2, 3, 4. Just skip past slides.
I think you might have like skipped the one we are on right now because it like immediately hopped in the explanation to the other one. We just went over.
This is it. This is the one we went over. Okay.
Yeah, that's the one we just went over.
Now, okay, next one.
There we go.
This is it. Okay, so now we want to find APY. So this is a little bit maybe of an involved process, but we want to find the APY is basically the relative increase for 1 year. So we want to find APY, or annual percentage yield. Find it to the nearest 0.01% in each case. Okay, so we're finding it to the nearest 0.1, we're rounding it to 2 decimal places. A bank offers an APR of 3.2 compounded monthly. So that you might notice they're not giving us a principal here. And part of that is because it really doesn't matter what principal you have. Your APY should be the same no matter what. So there are some numbers that are really nice to choose. I would probably go with P equals 100. I think that's what I did in my work. You could go with P equals 1. That's probably equally as good. You might have to convert it to a percentage afterwards. I would go with that. And so we want to take this. Get out of here. Take your principal of either 101. Go look at this thing. And they said we had what, APR of 3.2%? Is that what I heard? I think so.
Yeah, it's 3.2%.
And it's monthly, right? Is the information that we're given. So that's kind of the pertinent information I think that you need. We want to go look at these formulas and we say, hey, which formula can I use? Can I use the one compounded once per year? Probably not. It doesn't say the word continuous anywhere in that problem. If it's continuously compounding, they will tell you it is continuous compounded. They will use this word continuous somewhere in there. I don't see that word anywhere in the problem. Probably not going to use this one. So I think I'm back to this one. I want to figure out my accumulated amount. And then I want to take that and I want to figure out what my relative change was. I'm trying to draw my little line here. Ooh. And we're doing this for 1 year. So if that's what's confusing you, that's our what, Y variable, I believe. I'm just slowly giving y'all more and more to this. I feel like maybe I'm giving y'all too much. And I think monthly tells me my N is 12. Two decimal places, but it's got to be a percentage. So make sure you convert it to a percentage. Round it to 2 decimal places. Okay. But doing a principal of 100, it makes it really easy to convert it to a percentage. It's a little bit, it's a cheap gimmick. I'll say that much. But it's fair. It's like scratching on the 8 ball. You still win, you know. I got any billiards or pool players? I got a kinesiology credit or physical education, whatever they want to call it, for taking billiards at a bar of all places. Had class in a bar. I also had class in a bowling alley. Till I'm physically fit because I bowl and I play some billiards. Oh, whew. Oh, man. Oh, man. Where are we at? You are going like, I know that ain't me. Like, now that I look at the time, like my other class was faster than this. And I don't think this is, I don't think it's me. I think you're just being slow today. If I'm being honest. Yeah, I mean, like, it's like, this not, I don't know. I need y'all to be here and be active. I don't know what to say. Like this, we're starting out a new chapter, new section. Look at these 3 formulas. Look at all these other formulas. If you're gonna like start slacking off here, I don't think you're gonna do too well here, just being honest. Now's the time to be here, and now's the time to be active. Now's the time to have a calculator and check if and see if it works. See if you can get what we're getting. If
I'm
not, like,
trying.
yeah, I mean, appreciate it.
I had a rough couple of days, but I'm trying.
I think you're submitting stuff there, aren't you? You're here.
Yep.
Yeah, you're here and submitting stuff. Like I'm talking
I'm
about these.
trying.
I'm talking about all these other people. You see all these
Yeah.
other people? There's like 8 people who hadn't submitted nothing. 7 people, 6 people. And like I kind of gave you all the variables to fill in. Yeah. Even if you do things out of order or wrong, you know, in the wrong order, it's all right. See what you did wrong. That's the whole purpose of this homework. But you got to do something. You got to try something. And these aren't that, they're not that big of formulas. There's like 5 or 6 little operations you got to do. 3.25 should be what you're getting. So I don't know where you're getting a money amount. It should be calculator messing up. Well, I don't know what to do.
I liked that answer. Calculator messing up was just like, I don't know what else to type. There's my excuse.
Yeah. Okay, so let's see how we get this. If you have 3.2% compounded monthly, so we're filling in everything. We're starting off. They didn't give us a principal, so I just selected my own principal of 100. So if I start off with the $100 principal, I do 1 plus. I convert this percentage to a decimal, divide it by 12, multiply by 1 up here. So I maybe didn't break this up into steps, but the first thing you're going to do is divide what? 0.032 divided by 12 is going to give you what? 0.0. Ooh, that's not right. All right. 0.032 divided by 12 is going to give you something like 0.002666 repeating, right? I'm going to add that to 1. It's going to give me 1.0266 repeating. I think what I end up with is 100 times what? 1.0266. And like I said, if you don't have to round it, don't round it. I really like technology because it does it for me, right? I can kind of save it into my calculator. I can recall my answer and not have to round it. So 100 times this is where I'm getting the 103.24. I want to know the relative change. How much did this go up relative? 3.24. If you do 100 is your principal, this is the percentage already. If you did 1, you'd have to convert it. Does this make sense? So they say my APR is 3.2% and it's compounded monthly. So where are you expecting this to fall? It should be a little bit more than 3.2%, right? 3.2% would be if it was compounded once per year. If we start compounding it more times per year, we should start increasing that rate. Not a whole lot, but just a little bit. So it should definitely go up a little bit the more that you compound it. So if the annual rate's 3.2, the actual rate will be a little bit higher because we're compounding it more than once per year. All right, so planning ahead, how much must you deposit today in each of the following accounts in order to have $25K in 8 years for a down payment on a house? Assume no additional deposits are made. And the account that they give us, it's an account with monthly compounding and an annual percentage rate of 6%. So I'll give you a little bit of a hint. We want 25,000. This is not how much we're starting out with. This is not a principal amount. This is how much we want in the end. So that 25K should be the accumulated amount. We don't know the principal. That is the thing that they're asking for here. How much are you going to have to start with to get that amount? They give us the APR. They give us that it's monthly. They give us the number of years. I forget what they are already. What's going to happen is you're going to crunch this number here. This is all a big nasty number over here. But it's just being multiplied by P. So if this is being multiplied by P, how do we get it off of P? What's the inverse of multiplying?
Divide.
Dividing. There we go. I had to pull up the chat too. Okay, so you should plug in everything. This should be your 25K. Should plug in all the information from the problem. Let me see. I bring it up on my phone. I could read the problem and the formula at the same time. We're doing 25K for the accumulated amount. The principal is what we're trying to figure out. We're doing 1 plus. My annual percentage rate was 6%. I know monthly compounding, and I want to talk about this thing for 8 years.
What does the N mean again?
That is the number of compounding periods.
Okay. Thank you.
Here we're talking about monthly. Yeah, so that this might be something to talk about, right? So there are two sort of like variables that are both talking about time. N is the number of compounding periods per year, and then Y is the number of years. Don't mix those up. Round it to the nearest whole dollar.
I may have messed up somewhere, but I don't know.
Yeah, I mean, you got to try something. I don't know.
Yeah, because it was a small number because I did per month.
Yeah, I mean, it'll be broken down on the next slide. So if you do mess up, it's not a big deal. The more important thing is that you realize why you messed up, right? That's the process of learning. And that you understand how to do it correctly.
True.
Not necessarily that you get everything correct all the time. Yeah, like you got to kind of step outside your comfort zone a little bit to learn sometimes and get stuff wrong. Okay. I feel like that should be a pretty good amount of time for this problem. Been on it for like 2 or 3 minutes at least. Hmm. Oh, we're doing 1588. Those should be all correct. If you route it to the cents, it's not going to do it. Okay. Okay, so if we start with an account with monthly compounding and an APR of 6%. This is the formula we're using. Oh, I guess I put R instead of APR, didn't I? My other book has different variables. But anyway, that should be APR. We plug things in. I told you the accumulated amount is the thing that should be the 25K. So they're not giving you principal here. So there's a little bit of back solving that you might have to do. So there are 2 steps. I'm probably just going to start combining into one. The first thing I'm doing is I'm dividing this. It's going to give me a decimal and I'm adding it to 1. So I have 1 plus whatever the heck decimal this thing gives me, which is 0.005. The other thing here, I can multiply my exponents. So 8 times 12 is going to give me 96. So what I'm doing is I'm going to my calculator now to do 1.005 to the 96. Gives me like 1.61 something, some change. So I know I copied and pasted. These decimals might not be exact, but my solution should be exact. So if we want to find P, this was kind of the hint I gave you. We want to take that 25K. We want to divide it by the 1.61 we found. And if you do that, that should give you somewhere around what, 15,488 and 10 cents. Which I think someone said. Any questions on this? If you didn't get this, do you understand why you didn't get this?
Yeah, it turns out I put the wrong number for the, well, right number, wrong exponent.
Okay.
I had the right idea. I just did it wrong.
Yeah, same. The minute it was pulled up, I was instantly like, ah, so that's what happened.
Okay. I think this one is really similar. So I guess let me go ahead and read the whole thing on here. College funds, so how much you deposit today, and we want to, how much you deposit today in each of the following accounts in order to have a 120K college fund in 15 years. So no additional deposits are made. If it was, we'd have to use the stuff they haven't taught us yet from section 4C. So we have an APR of 2.85%, and it's compounded now quarterly. So that thing changed. We have an APR of 2.85% compounded quarterly. This is, I don't give y'all too much, but that's my accumulated amount. And doing it for 15 years. So this should look really similar to the previous one. Make sure to convert this to the decimal correctly. Move it the right amount of spaces. Make sure you do quarterly for 15 years.
We're using the same formula as before, right?
Yep. I think we use that formula for pretty much everything. There might be one example where we got to use this one. And if I recall correctly, we don't use this one at all. Although you might use that one in your quiz and your test. And so you should know how to use it. I don't know why they didn't give us any homework with it in there. Oh, whew. How did that happen here? Are y'all getting this?
Man, I hope I did that right.
Are y'all like, I don't, man, I just like, I really don't know if I'm just being impatient. It might be me being a little bit impatient, but I feel like, yeah, there's this like, usually y'all are like a little quicker than the other class, and you're like, y'all are just slower today for some reason. So I feel like maybe,
Maybe it's a last day of the month kind of thing.
yeah, get your coffee in, get your yerba mate, whatever you need.
Wait, we're usually the quick class?
Yeah. Yeah, I mean, I don't want to say that because it's not saying a whole lot. That's true. Yeah. I don't. Things are a lot more visual and obvious when things are online too. Certain things are when you're a professor, like class inactivity. If you want to like slunk off in like the corner of a class, there's a good chance like I could probably miss you, you know. But when it's like online right here, like I can see right now, 4 people aren't responding to this yet, right? It's like really obvious you're not participating when it's online in this format. And not only is it obvious, it's like it's really well documented. So like, if there's any sort of discrepancy, I could just sort of look back at what you did, you know, or what you didn't do. Might be the more apt. With that said, I have it written right here. April 26th is the final withdrawal date. ACC has a pretty late withdrawal date. So response, what are we on? 788, 375. Ooh, you're a little higher there. 708, 78, 75. Yes, it looks like somewhere a little high. I don't know. It's hard to know where you went wrong, you know, on these questions, unless you're going to tell me, unless you want to, which I understand, like there's that social pressure. You don't want to admit you got something wrong.
Ah, that's what I did wrong. I put a 3 instead of a 4 because 12 divided by 4 is 3.
I put the 12, like 12. I think I just automatically assumed like monthly by accident.
Okay, so we're looking here.
That's where I went wrong.
N says how many times is this compounded per year? So if it says compounded quarterly, quarterly means 4. If they say semi-annually, that would be like 2. If they say monthly, it means 12. I'm trying to think what else. I think those are probably the only options they'll give you. Those are the most common ones, at least. I guess they could be weirdos. But here we have 120K is my accumulated amount. I do a little bit of number crunching. So what did I do? I divided these two numbers and then I added 1 to it. So it's 1 and whatever the heck this fraction thing was what, 0.007125? I think I also combined these two things. So you do have to multiply these before you raise it. It's sort of like these things are in parentheses up here as well, right? That multiplication comes first. But we do this 1.007125. We raise this to the 60th. We should be getting that crazy number, 1.53 and some change. Then the last step, similar to what we did before, is we're taking that 120K. We're trying to figure out what P is. So we're dividing it by that number to get P by itself. Questions about this? How quick should I hit the next key? Are we getting it? Do you need to look at this for a second longer? You can always scream at me and go back if you need to. Ding, 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 ding. Okay, so now what are we answering? Is this, there's one that has like 2 people in it, and I really broke it apart. Let's look at the question. Yes, this is it. This is Chang and Kyo. So we have small rate differences. So what they're trying to do is they're trying to hold everything the same except for your APR and just tweak your APR a little bit. Give you an idea of what that does is what they're trying to do. trying to hold everything constant. So they're saying something about like the following pairs are identical except for their interest rates. Compute the balances in both accounts after 10 years and after 30 years. So there are 4 different things we're gonna have to calculate here, basically. We have Chang investing 500 into an account that has 3.5% compounded annually. So I think we might be able to use that simpler one on this one. And Keo invests 500 in a different account that earns 3.75%. That's also compounded annually. And so the first thing we want to do, Chang for 10 years. So Chang invests 500. This is the poignant information. Chang invests 500 into an account, earns 3.5% APR compounded annually. 10 years, and we're looking here. I think you can probably use either one of those. And we're doing Chang for 10 years. So he's starting with $500 for 10 years.
Compound annually means 12 months, right?
If you're doing it annually, how many times per year are you doing it?
Shoot, why don't I remember that?
It's once, right? Just annual.
Okay.
Annual means
Right.
yearly.
Okay.
It means once per year. So if
Once
you're doing
per
it once per year, I guess you could plug in 1 into your in here.
Okay.
If you do that, you might notice it's really just this formula. APR divided by 1 is just going to be my APR, right? My 1 times my Y is just going to be my Y. So this is the one you can use that first formula. I would use the first formula. If you don't, you're going to use the second formula and it's going to become the first formula, basically. Okay, where are we at?
Just give me a minute. I'm a slow typer. I'm a slow worker.
Oh, you're killing me.
We just heard his soul leave his body.
Okay.
I'll be right back. I'm gonna go get a snack for myself.
Yeah, I had to take a break myself real quick. But anyway, let's look at this. $705. What else are y'all telling me? What could it be? That's a little high. $705. I should be able to do that first formula. So if we're looking at this first formula, we're plugging in 500 is my principal. My rate is what, 0.035. My T is my time. He is going to do this for 10 years is the first thing we're doing. The next problem, we're going to find the same guy. We're going to do is the same account. The only thing we're changing is we're going to go to 30 years. So a lot of times if you do the work or you set things up, you might save yourself a little bit of time in the next problem. I think we're doing the same guy for 30 years. If not, we're changing the other guy. If I do 1.035 and I raise it to the 10th, I should get something like 1.41. I multiply that result by 500 to get my 705. Any questions about this one? All right, so I'm hoping you get this down. The next one should look very similar, so hopefully it's a little quicker. I believe we're still doing Chang. Is that what I'm asking for? Chang for 30 years now. Oh, that is like a two-step problem almost. Maybe a Texas two-step, but maybe I didn't put money in my amounts. That's another thing. You got to put your dollar sign in there. I almost forgot. You ever notice when people try to like give you advice, that's usually the stuff that they're doing wrong? It's like, don't do that. It's like either something I'm doing wrong or something I'm seeing people do wrong. Oh man.
I'm back. Did I miss anything important?
No, we don't do anything important in here.
Okay.
So now we're doing Chang for 30 years. I ended the other slide.
Okay.
So it should look very similar to what you did. If you got the previous one right. Oh. Okay. Mhm. So what are we getting for this? This one shouldn't take too long if you know what's happening in the previous one. Yeah, if you're understanding this, then hopefully you're getting this one. 1403, that's it. And so let's look at how this is done. Same problem basically. The thing that changes here is my t or my time changes from what, 10 to 30 from the previous one. So if we change that, this is 1.05035 to the 30th should give me 2.8, somewhere in that ballpark. I round it to 500, or multiply it by 500, and it should round somewhere to 1403, what, 40? If I rounded it to the nearest cent. 1403, 1404, somewhere around there. Small rate differences. So now we are doing the same thing, but now we are doing the thing for Keo. We're doing 10 years with Keo. So my T is 10. My rate here is 3.75 now. So we're just bumping up by like what, 0.25% points is basically what we're doing. Same amount. We're going for 10 years, $500. So we're keeping everything else constant. And this should take like 30 seconds to do after those. After those previous two, this one should be a little bit easier.
Wait, just so we're just going over practically what we did. Like homework is done pretty much, right?
No, this is the homework problem. We're doing Chang and we're doing Keo. We're trying to compare these two accounts. And we're doing them for 10 years and we're doing them for 30 years.
Got it. Okay.
And how much each one of them has. So there's 4 different things we're finding out. Okay, yeah, that's it. Okay. That should be enough time. What are y'all doing? Oh man. Mm-hmm. Yeah, I don't know what to do. If you're not getting this, then this is the time to ask questions, I guess. But we've done this, and this is the third time we've done the same thing kind of over and over again. Next slide will have the description. So 10 years for Keo, so same formula. The only thing that changes here is my rate. My rate is 0.0375 now. I'm still doing it to the 10 years. I'm raising 1.0375 to the 10th power. This should give me somewhere around 1.44, and I multiply that by 500, should give me 722, 723 if I round that up. The next thing, the last thing, and I'm going to give you 30 seconds on this, in literally 30 seconds, because y'all need to be active in doing these same things. It should not be taking y'all near that long. We are doing Keo for 30 years now. It's the same thing. Instead of 10 years, now we do 30 years and $500. Okay. And what are we getting here? 15.09, I think is what we get if we round it up. And so it's the same formula. Basically, we would do 1.0375 and we're raising it to the 30th power. Should give me something like 3.017, somewhere in there. Multiply that by 500, should be giving me the 1509. And so now the question was to compare these two, right? So Chang versus Keo. Chang in 10 years has 705 versus what? 722.52. So I think the book, I think they give a relative difference and an absolute difference. But if we want to figure those things out, let's do that right quick. I think what the book does is give absolute and relative difference. So if we do the absolute difference, if we subtract those two numbers, I believe the first two is giving us a difference of 1722. If we do the relative difference by dividing it by what, 705.3, this is giving me something like 2.44%, I believe. And so what is that? That's that one. This other one has an absolute difference and relative difference. Well, he may not. It depends, right? It may not be a better account. It depends what he's using it for. But this one is an absolute difference of 105. 34, it's got a relative difference of 7.5%, something like that. If you were to investing for 10 years, well, he's still lower there. Never mind. Yeah, it is better. But it is better across here. But if we look at sort of how this thing goes, is what they're wanting to look at, the rate at which it's better in the short term, right? It is like only about $17 better. If you're talking about $500 and you're talking about $20, that's not a whole lot. It's like 2.4%. But in the longer term, over the long term, the thing about compounding and the thing about exponential growth in general is that it not only grows, it grows upon its growth. So you're not only higher here, but you're proportionally also higher, right? You're getting a larger and larger sort of amount as time goes on. So you get the interest on your interest, makes your overall rate higher. Is I think what they're trying to get at here is that not only does it increase, the rate of it actually increases as well. Okay. Blah, blah, blah. What are they telling me? Yeah, okay. So yeah, he got and his rate's not like all that much larger, right? We're talking about fractions of percentage points. And so in the short term, you're not really going to see a large sort of return on that or a large difference. But in the long term, those things are going to get way and way more farther apart. Is sort of what that tells us. And so the next one, Willie, you better chill, boy. Your bank account, find the APR, find the current APR, the compounding period, and the claimed APY for your personal savings account. Okay, so that I found this out for you. I did a little bit of research, but I found this at my credit union. This is what they were advertising. So this was what was in the big bold print. You could go find the APR or the APY. You could probably go dig that out. I think it was somewhere in there. But this was the bold sort of font. They told me there was 0.1% interest rate paid monthly. So this is giving me what? APR, and this is giving me my compounding periods. And we want to see if that is 1% APY. And you probably already know they use some sort of nefarious sort of language there, up to, right? It doesn't necessarily mean that you're going to get that. But if we do 0.1% interest rate, is it giving us a 1% APY? How do you figure that out? So that's what they're asking. Calculate the APY. Does it match what they're claiming here? But just using what you know about like APRs versus APYs, do you think you're going to get a 1% APY from something that has a 10% or 0.1% APR? I almost like really love like staying here for a long time. I don't know what the deal is. I got office hours after this. I ain't got nothing planned. Interest rate is 10%. I don't know where you're getting that from. Okay, so the $0 monthly service fee, that's not referring to the principal. That's kind of irrelevant information to figuring out the APY. I'm not sure where people are.
I think it's either like not entirely sure or typing a long paragraph or I'm not sure.
Yeah, I don't know. I mean, we're already like, my other class finished like right in time, and we're already like pushing over class time right now. So I I personally don't understand people's approach to like taking this class or to like, I don't know. I'm just like kind of baffled because it's like we have homework. I kind of put that out like, you know, the work that we're gonna do, right? I'm not sure we're getting 10% for the APY. If you calculate the APY, it shouldn't really change from your APR. It's like so little, right? You're talking about 0.1%. And so I think that's what I did on the next slide. I think I calculated APY from the 0.1%. So I think maybe you got to convert it, right? So when you convert 0.1%, it should be oh, did I fix this? I hope I fixed it. Come on, slide. So when you convert 0.1%, there should be 2 decimal places. We're doing it monthly, so this is 12. We're doing it for 1 year to find my APY. And so my principal is the thing they don't give me, but if I'm smart, I can pick something like 1 or 100. So if I'm calculating my APY, this is my accumulated amount. If I subtract that from 100, you might notice I'm getting like 0.1. I'm getting this decimal right here, right? I'm getting 0.1 and there's like 3 zeros behind that. So it's increasing it by like this amount. That's not even significant enough to like 2 decimal places to change it. So it's still going to be about 0.1%. It's not going to be 1%. That's 10 times the amount. So their claim that it's up to 1%, it's, I guess, technically true, but this is not for this account. And they said something about for all accounts, we have this up to 1%. I guess that's true because you can have next to nothing and it's still up to 1% is the maximum. Like that doesn't tell me anything. What's your minimum, right? So their wording's a little weird, and it's a little weird because they're trying to sell you a product, right? Suppose you receive a gift of $10,000 and place it in your account. If the interest rate never changes, how much will you have in 10 years? So here we have all the information, and you have the formula you need. You should be able to pick out what formula you need from that list. But we have 10,000, sounds like my principal. We're going to place it into an account. My interest rate is 0.1%, so you got to convert that. How much we have in 10 years, and we're going to assume, I'm pretty sure that we're doing things monthly.
It's just the same formula from Plan A, right?
It's pretty much the same formula we've been using all throughout this thing, I think.
Okay.
The second one on that list, right? We're doing monthly compounding. So back to n equals 12. Yeah, I think we've got like 2 more questions left. Oh. Got Giacomo Fini trapped in my head now. I go back one day. Giacomo Fini, Giacomo Fini. It's like the most Louisiana song out there, I think. Aiko, Giacomo Fini. It's all about like two parade floats crashing into each other and a fight ensuing. It amuses me now that I know what it's about. Where are y'all at, man? There's 8 people. That's half the class. Just like falling asleep. Okay, we're almost there. I'll give y'all 30 more seconds. It's not like we've done anything like this throughout the whole class. The other thing was Dr. John was one of the famous ones that, or one of the people that made that song famous. And it always amuses me that like Dr. Teeth is kind of loosely based on him from Electric Mayhem, the Muppets. Okay. We have done a few of these. Did you get 10 or 100? Yeah, I got 10 or 100. 10,100, I think is what the number is. So we are doing the principal is 10,000. My interest rate here is completely wrong. This should definitely say 0.001. So let's pretend like that doesn't say that. I thought I corrected all of them, but I guess I didn't correct this one. So there we go. That should say 0.001 divided by 12. I'm pretty sure I did that in my calculator to crunch the numbers anyway. It shouldn't mess us up, but we should get something like with 4 zeros and 83 repeating, something like that, when we plug this into a calculator. 0.001 divided by 12, and we're going to add 1 to it. 12 times 10 gives me 120, and the exponent, my base, is this crazy number. My exponent's 120. I plug that into calculator, and I get this crazy number. I multiply this crazy number by the 10,000. Should be giving me 10,100. And the last problem, I believe, it says something about tripling it or something. That's too high. Or adding 2 percentage points. That would make your rate way too high from what it is. I think tripling it might be better. So basically we're going to do the same thing, but now the one thing that we're going to change is we're going to make our APR 0.3%. So if we change our APR to 0.3%, how does that change the amount that we expect to get? So everything else the same. 10,000 principal plus, now my APR is the 0.003. I am still compounding this monthly and doing it for 10 years. Oh, don't be in a hurry or anything. It's just the last problem we gotta do.
Hey, I gotta meet with someone. Is it okay if I go?
Yeah, it's fine. I can't hold you after class at all. I can only guarantee you'll be here till what, 4:20. We're about to be done. This is the last problem. Good luck. All right, same problem. We literally just changed one number. So instead of 0.001, it should look like the same thing, but 0.003. So I'm not sure, but I think that's as much time as I really must spend on this problem. Okay, what y'all telling me? 10305. What else? Are y'all like? Did I not? I don't know. Okay. Yeah, I was just looking for that number. It probably said explained. All right, so is this the same one? Did I go back? No, that's it. I guess I just didn't change
That's
it
the
from B
last
to
slide.
C.
I don't.
Yeah, I just didn't change it from B to C, so it should be. I forgot, but that is the work. It should be 10305, so it should be what, about 300 more or 200 more. And that's only from changing it, what, a few percent points. So they're just trying to get you to have like a sort of feel of how your APR influences your overall rate. And a lot of it depends upon also how long you're going to go with it, right? So that is it. If you got questions, I am here at least until what, 5:30? That's my office hours end.
Bye.
All right, take care. Stop recording.